guys, welcome back to the continuation of the chapter of acid, bases and salts. We have made one salt in the previous recording, and in that class we have discussed this thing that how we can prepare a salt through titration method. In this page I have shown you how to write the method for the sodium chloride preparation. Now I'm going to take you to the next page so that you people may learn further practice regarding titration. Okay, so for example, let's take an example of another salt, but it is of ammonium family. It is like ammonium nitrate. Okay, formula NH4NO3. Okay, guys, I'm telling you and keep on telling you that it is very important for you to keep the formulas in your mind. Okay, so whensoever you are finding any formula on any page or on any voice messages or recordings, etc., etc., it is really important to keep one set of record on your own. Okay, so look at here right now. It will be prepared by titration method. Why it will be prepared by titration method? Because it is a salt of ammonium family. So all those salts which are part of ammonium family or the part of group number 1, they will be prepared by titration method. Okay. Now, as it is a part of ammonium family, ammonium nitrate. So what will be the two reactants which are reacting with each other to give you ammonium nitrate? It will be, one of them will be nitric acid. Why? Because it will become a source of this HNO3 will become source of nitrate. Okay. Whereas ammonium part will be obtained from ammonium hydroxide. Ammonium part will be obtained from ammonium hydroxide. Okay, and this is this ammonium hydroxide. Okay, NH4OH is called as ammonium hydroxide. Okay, now we can say this thing that nitric acid is becoming source of what? Nitrate. Okay, whereas ammonium hydroxide is becoming source of ammonium part. Okay, I'm marking an arrow very clearly. Whereas these black lines are telling you that this hydrogen and this OH are combining with each other to give you the other partner, and that is called water. Okay, so this way we can say that in all titration method salt, we are getting not only the salt, rather water is prepared as well. We must know this thing that both of the partners of titration method are soluble in water. Okay, so HNO3 is what? HNO3 is an acid. If you people will recall the list of the acids in your mind, then it can become easily in your mind that nitric acid is an acid, HNO3 is the formula of an acid. Okay, whereas what about ammonium nitrate, ammonium hydroxide, metal oxide, metal hydroxide, metal carbonates, and ammonia are called bases. Okay. Ammonium hydroxide is ammonia dissolved in water. Ammonium hydroxide is called as aqueous ammonia or ammonia solution or ammonium hydroxide. All three are representing the same thing. Okay, so this is an alkali here. Okay, so for this example, we are taking just consider thymol phthalene as an indicator. Thymol phthalene, and I have told you the colors that mole phthalene in the acid is colorless, whereas in an alkali, it is what color? It is, you may say, blue in color. Okay, so these are the color changes regarding thymol phthalene. And now in this case, we are taking acid in the burette, and definitely we are going to take alkali in the conical flask. Okay, now I am changing the page so that I may write the whole method and you people may learn how to write ammonium nitrate preparation. Okay, here we can take ammonium hydroxide in the conical flask. So what we have to say, 25 centimeter cube of ammonium hydroxide is taken in conical flask in conical flask with the help of a pipette, full stop, 2-3 drops of thymol phthalene are added, full stop. Blue color is observed, full stop. Drop wise, burette partner will be always added drop wise. Okay, drop wise, HNO3 is added from the burette, from the burette to the flask until the color change, until the color change is seen from blue to colorless, from blue to colorless. Okay, now one point which you should know is this, that color changes are always very clear. So always write down the first color according to the flask and the second color according to the burette. Okay, at the end point at which the reaction between the two partners is completed, one drop of the burette partner is in the more amount, is more than the required amount. That's why the final color is according to the burette partner. So here the burette partner is an acid, so we are writing from changes seen from blue to colorless. Okay, so here we are going to say titration is repeated, titration is repeated. Why repeated? So that we may do it without indicator. Titration is repeated without indicator, without indicator, comma, to avoid the contamination of indicator, to avoid the contamination of indicator, full stop. Salt solution is shifted, salt solution is shifted from where to where? From conical flask to china dish, to china dish, comma, heated till saturation. On which thing we are going to heat it? We are going to heat it on a Bunsen burner because it has a high boiling point. It will not get a flame as well. So that's why it can be heated on a Bunsen burner. Okay. Flask to china dish, comma, heated till saturation or crystallization point. Heated till saturation, full stop. Salt crystals are obtained through filtration. Salt crystals are obtained through filtration, full stop. Washed with alcohol. I have just told you in the previous video that all salts which will be prepared by titration method will be washed with alcohol. All those salts which are prepared through excessive reagent method will be washed through alcohol, and all those salts which are prepared through ionic precipitation are washed through water. Okay, so this is an important point which you need to keep in your mind. How we are going to wash a salt, it is really very important. Okay, washed with or washed through alcohol, dried in the folds of filter paper, dried in the folds of filter paper. So from these two salts, this should be clear in your mind that how we are going to prepare a salt through titration method. Guys, sometimes examiner is asking you to write down the balanced chemical equation for that reaction as well, for that salt which you are going to prepare as well. Sometimes it is important to write it, but remember this thing, that a good student is always writing that titration equation or any equation at the top of the method, and then he or she is explaining the method in the following lines. Here I have written the whole thing in like many lines here on the board, but here I'm using a soft board, so you people can use lesser number of lines as well. But I have told you in the previous lecture that might be examiner will give you 5 to 6 lines, or might be 7 to 8 lines as well. So you are expected, we are expecting from you to write lots of information. Not lots of information means that you are writing the information of Mars or Moon on it. Obviously the information related to that, but be aware that you are writing each and every point used in the salt preparation. So this is the practice for the titration method. Now I am taking you to the next method. Before moving to the next method, I would like to inform this thing to you all very clearly, that this indicator thingy is used in titration only. Okay, indicator is used in titration only. Is that okay? Indicator is not used in excessive reagent method. Indicator is not used in ionic precipitation as well. Is that okay, bro? So please keep this thing in your mind, that you are not going to use indicator in any other method. Okay. So right now I'm going to take you on another page, and this is related to the next method, and that is called as excessive reagent method. Okay. Excessive reagent method is basically used for all those salts which are soluble. Soluble means soluble in water. Soluble but not part of group 1, but not part of group 1 or ammonium family. Okay, so this is important, that you should know this thing, that you are going to prepare a water soluble salt, but it is not part of group number 1 or ammonium family. So remember this thing, that it will be prepared by excessive reagent method. The name is sufficient to tell you excessive reagent method, that one of the partner will be used in the excessive amount. Okay, so one of the partner, which one of the partner, and how we are going to decide that, all the things I'm going to discuss with you. Okay, now the first point which I am going to tell you is this, that no indicator will be used in this case. No indicator will be used. Okay. And number 2 point is this, salt prepared. Salt prepared is washed with alcohol. Okay, because it is soluble in water. That point I have already explained. Okay, now I'm changing the page, and I am telling it to you that how you are going to decide which reagent will be in the excess. Okay. So here the salt is there, and it can be prepared by the reaction of metal with acid, all right, or metal oxide with acid. Okay, and the number 3 possibility is metal hydroxide with acid, done. And number 3 possibility is metal carbonate with acid. Okay, can we categorize this reaction as neutralization as well? Yes, we can categorize this excessive reagent method as a neutralization as well. But if we are going to use the first method, that is metal and acid category, then it will not be categorized as a neutralization reaction, because in neutralization there must be a base or an alkali reacting with an acid. But in this case of metal and acid, base is missing, alkali is missing. That's why we cannot categorize it as neutralization. Now, the point is this, that all these categories are giving you what? They are giving you salt and water. Okay, but the category number 1, salt and water, and the carbon dioxide is exceptional, or water is exceptional. Okay, how? Let me inform you. If you are reacting metal and acid, then only salt will be the product. If you are reacting metal oxide and acid, then the product will be both. These two will be the both products in case of metal oxide and in case of metal hydroxide. But if you are using this, I mean to say metal carbonate and acid, in that case salt, water and carbon dioxide will be the product. Okay,